One type of word problem that can come up on the AP exam is one that relates back to percent yield, and that's what we'll be talking about in this video right here. Let's consider the following. Let's say we're in a lab situation, right? And we're doing a lab like this. We're adding some sodium hydroxide solution to aluminum chloride solution. It creates sodium chloride solution and it precipitates aluminum hydroxide. Aluminum hydroxide looks like this. And maybe I tell you, after the reaction is complete, you should have around 3.5 grams. And then you look and you see you actually have 2 grams. Is this because you're a bad student? Is this because you didn't follow the directions? Absolutely not. It's because we have a percent yield for this reaction that I didn't tell you about. So you might be asking, what is a percent yield? Well, percent yield first and foremost is a percentage. And a percentage is simply a ratio. A ratio is like a fraction, so it needs to have 2 parts. In this case, a percent yield is made up of the following. An experimental amount of product is divided by the theoretical amount of product. If you don't like the word experimental, if that confuses you a little, consider the phrase actual, right? It's how much you are actually making when you enter the lab. It's how much you actually created based off of the word problem information. And if you don't like the word theoretical, consider the phrase ideal, right? If we lived in a perfect world and every single reactant turned into the product, how much could we make? Now this is based off of the limiting reagent. One last thing to consider is when we are talking amount in the chemistry class, we are always talking about moles, right? We could talk about grams, we could talk about milliliters, but 9 times out of 10, we're going to be using moles to help us determine what the percent yield is, or to be able to use the percent yield to determine an experimental or theoretical amount. But enough chit chat, let's see a real AP chemistry example of this kind of problem. Let's take a look at a real AP chemistry exam example. This comes from the 2015 free response section. As we note in part B, we can see that they ask us to calculate the percent yield of ethene in the experiment. Well, what is percent yield? Well, let's remind ourselves it's the experimental amount of product over the theoretical amount of product. Now, if you look at this problem, there are some things we haven't yet learned how to do. So we're going to ignore A1 and A2, but I'm going to give you some information that you need to know. The actual amount of moles that I created from this reaction is 0.00264 moles of ethene, C2H4 gas. With that information, we can now go and determine the percent yield of this reaction. Well, how do we do that? We're going to look at the information that they gave us. A student added 0.22 grams of ethanol, C2H5OH, to a test tube. Remember, the theoretical amount of product here is based off of the limiting reagent. And since there's only one reagent, it has to be the limiting reagent. So we've got 0.200 grams of ethanol, C2H5OH. I'm going to want to convert that into moles. That way I can go from moles of ethanol to moles of ethene. So the molar mass of ethanol is 46.07 grams of ethanol for every 1 mole of ethanol. Now that I'm in moles of ethanol and no longer in grams of ethanol, I can use the mole-to-mole ratio of that equation to determine my theoretical moles of my product, ethene. So let's do that. For every 1 mole of ethanol, C2H5OH, I have 1 mole of ethene, C2H4. And when I do this math out, I get 0.00434 moles of ethene, C2H4. Well, hey, now I've got all of the parts I need to determine the percent yield, right? My experimental amount of product, my actual amount of product that I made was 0.00264. The theoretical amount is how much I could have made based off of my limiting reagent, which is the only reagent here. So that would have been 0.00434 moles of ethene. I get a final answer of 0.608, but we need to convert it into a percentage. So that becomes 60.8%. That is the final answer for part B of this question. I realize we may not be able to do A1 and 2 right now, but based off of the information I gave you, you can also calculate the percent yield for this kind of equation. Thanks for listening. Let me know if you have any questions, and good luck.